I thought it was too.
Okay, so little bit about strategy on the test, okay? So for those of you that are watching on YouTube, so first question I gave them, and you can pick this up in class, is this question from 2024, which was like a couple of years ago. So you're going to have two distinct parts of the test. You're going to have the multiple choice, and you're going to have the free response. So I tend to focus more in the study sessions on the free response part of it because it tends to be more encompassing. It tends to cover like broader strategy. So there's a couple of things that are specific to this particular question and why I asked and why I started with this question. So one of them is on part B. It says the following contains the atomic radii for silver and copper. And it has the radii in picoliters, 165 and 145. Okay. Copper is a little bit smaller, right? And then it says on part 1, explain why sterling silver is better classified as a substitutional alloy than an interstitial alloy. At this point, you all are flipping out going, my God, we've never heard of these terms before, right? And you are guaranteed almost that you're going to run into some questions on the test and you're going to go, holy cow, I have no idea what this is, okay? Because I'm somewhat limited on what I can prepare you for. And the College Board sets this up. They don't want people to get 100% of the stuff. They want a broad range of scores. So you want people like one of my nieces who took this test. So this was quite a few years ago. So she went to Capon, and they got college credit for the class, but they still had to take the AP test. But the score didn't matter. So if you write your name on the test, you get a 1. And so the AP board wants like a bell curve distribution of scores. So after she took the test, I said, how did it go? And she says, well, I drew a cat on one of the free response questions. I said, seriously? I said, yes. I said, you didn't work the problem. I said, nope, I drew a cat. Okay, great. And made a note to the grader and said, here's a nice cat. Okay. So I told that story to the class I was teaching at the time. I said, you want people like my niece taking this test. So like 2 or 3 years later, my niece goes to K-State and she's tutoring kids in differential equations. She's a chip off the old Uncle Nerd block. And so she's talking with this girl, and she goes, that she's helping, and she goes, where'd you go to school? And she goes, I went to Mays. And she goes, did you happen to have Stan Burkhamp? She goes, yeah, he was my AP chemistry teacher. And she goes, she goes, and then my former student asked her, she's like, are you the one that drew the cat on the AP test? She goes, yes, how did you know? Oh. And so it's okay. The point of the story is that there's going to be a wide distribution of scores. You don't have to get 100% on this test. And don't flip out if you don't. Generally, if you get a 70 to 75% or above, you're going to get a 5. Okay? So don't flip out. Now, here's the other reason why I put this particular question on here. So part of it is like, okay, let's just look at, you don't know the meaning of these words. Okay? So you have substitutional alloy. So what would you think that would mean?
Substitute.
Well, you can put one thing in for another, right? Okay? Now, interstitial that implies that it's going to go in between because it's inter, right? So you have one where you're going to substitute, and you're going to have another one that's going to go in between. So, with that being said, it says, explain why sterling silver is better classified as a substitutional alloy. So if you begin the reading at the beginning, and this is what I would do if I were you all, you're going to have a certain amount of time to take this test. I would look at the big picture. I would read the entire question and get an idea of how this thing is going to play out. Because a lot of times what they'll do is they'll start with one thing, and they're going to end up with something completely different by the end of the story. So when you get to like a question on part 1, and you read that and you go, man, I have no idea. Don't panic. Certainly don't say, hey, I'm just going to give up on the question because I don't know part 1. Okay? A lot of times there's multiple parts to these questions that don't have anything to do with one of the questions at the beginning. So if you get a question like that, don't look at this and go, oh, I'm doomed. I'm going to fail the test because I don't know what part 1 is on the question. Okay? So don't flip out. But now, using a little vocabulary we just talked about. Substitutional alloy, right? So what do you notice about silver and copper in terms of their atomic radius?
Silver's bigger.
Yeah, but they're relatively close, though. It isn't like 165 and 50, right? So in terms of spacing, in terms of a substitutional alloy, it says, hey, why is it better classified as a substitutional alloy? Because you can say, oh, these have a similar radius, so therefore it's easy to substitute those atoms into a compound, into an alloy. Okay? So even if you read this question, go, man, I have no idea. We haven't talked about that. Look at the wording in the question. Okay, great. Hey, substitute. I can put this in. Look at that. Hey, they're about the same size. Now, in interstitial alloy, this is like if you study how they make steel, they actually take carbon atoms and put that in, and they mix it in with the iron to make steel. That situation, carbon is a space filler. So even on an atomic level, iron atoms, right, have these spaces in between them. So you put in those carbon atoms, which are smaller, to take up that space, and that's what makes it stronger by that substitution. So substitutional alloy, you need 2 atoms that are the same size. Interstitial, you have gap-filling ones, because it's in between. That's what that inter means. It's in between the gaps. Okay?
So those radiuses would be super small, like this.
Yeah. So like if you compare a carbon atom to an iron or a copper or something like that, it's much smaller, so they can fill in those gaps. It'd be like putting marbles in between ping pong balls. Okay? Now, with all of that said, you should now, the rest of it you should be familiar with. Now, when you get to part 2, it says Coulomb's law. Coulomb's law is nothing more than F equals K times Q1, Q2 over distance squared. Coulomb's law is just the attractive force between the charged particles.
Really?
Okay?
Why?
That's Coulomb's law.
Why?
What do you mean, why?
Why are we doing physics
Well,
again?
we did this before. We haven't.
Because that's what, physics is what makes chemistry work.
I hate
That's
this.
why.
I hate this all.
Okay, so now, so Mara, stop you on your camera. I'm going to give you all about 10 minutes. Try and work through that entire problem.